I guess, to the island. To Island. And then they're going to have to return. He's going to have to return. I know I don't need a total column because never do they talk about the total. They don't say his total average speed was this, so I don't need a total column. The only time we need a total column is when we're mixing stuff together, or they say something like the total trip took 56 minutes. Then you might need a total column. They don't talk about that at all. They talk about each individual thing. Like I said, we're talking about speed, so immediately I'm thinking distance equals rate times the time you're going that rate. This is a perfect setup for everything. Anytime you're doing these tables, you should have some kind of equation up here with these letters. You should basically have something times something equals something. It can help you actually form which columns you're going to have. Yes?
You won't take off points.
I will not take off points if you don't use any table whatsoever. And in fact, I'm going to point out 2 mistakes I made on the homework. And I made them because I actually solved them first. And then I filled in the information after, which is a terrible way to show your work, is to actually do it all and then show it. Because I just knew what formulas we needed. So I'll get to that in a second, but let's finish this one. So we're going to the island. So let's fill in what information they give me. So Steve rode a boat from camp to an island. We already have that. Going to the island, the current. So we have some current increasing his normal speed by 2 miles per hour. So let's say his normal speed is y. I think I used y. We can use x, we can use y, we can use smiley face. I just want to keep the same thing I did for my answer key. So I'm saying his normal rate is y, but the current pushes him an extra 2 miles per hour. Going back, it actually decreases his speed by 2 miles per hour. So this is going to be y minus 2. The key part about those two statements are it increases and decreases, so the speed difference should be 4 miles per hour. So however you want to deal with that, this could have been y and this could have been y minus 4 if you really wanted it. But y plus 2 matches the situation better. Y minus 2 switches it better. They also tell me that it took only 1 hour to get there, and it took 3 hours to get back. And then it says how far is the island from the camp. So they didn't give me any information about the distance. If they didn't give me any information about the distance, they also didn't say, well, he went a different route going back, so it was 3 miles left. If they don't give you any distance, it is assumed that going there is the same distance as going back. But since they didn't give me any information, I'm just going to put an x in for both of them. That leads to 2 equations. It leads to basically x equals that y plus 2 times 1. And my other equation is x equals y minus 2 times 3. So now what you could do is use substitution. You could say, well, I got this, plug it in for that. Here's the problem with substitution. What variable would I solve for if I use substitution? Yeah, I would solve for y. I do not want to solve for y. You can, and then get x. But how many of us solved for y and accidentally gave that as our answer? 5 of you. So rather than that, I'm going to say how far is I want to actually solve for x. So if I solve for y, make sure you plug it back in. There is a way to just solve for x, and that is elimination. Yeah, what was that you were going to say?
I was going to.
Oh, I'm sorry. I'm sorry. What would I multiply this top one by to get rid of the y's then, using elimination?
Oh, I was thinking about something.
Oh, okay. I would multiply this by a negative 3.
Yes.
Because that's going to change that into negative 3x equals negative 3y plus 2. And let me just show you the picture of my work. And I only did that because I knew which variable I was solving for. So if you went ahead and you used substitution, more power to you. But just make sure you read the question, you look for which variable you're solving for. So I just used elimination. I came up with x equals 6. I was looking for x. I never at one point had a wrong answer up there. I'm not saying y equals is a wrong answer, but if you use it as your answer, then it's wrong. Yes?
Can we technically just do y plus 2 equals y minus 2? then solve for.
You'd need 3 times y
y
minus.
y minus 2 times 3, and then solve for y.
Yep.
You get 4.
Yep. But then we have to solve for x then.
Yeah, then you do.
So you take your y and plug it back in here. 4 plus 2x equals 6. Yep. That you use substitution. In short, because if you looked at what I was talking about before, substitution would be taking this, plugging in for x, and you would have y plus 2 equals 3 times y minus.
Oh.
You use substitution without knowing it.
I see now.
Can you go back to your book?
I sure can. Are there any conceptual questions about this? All right, then what questions do we have from the homework? Actually, before we go to questions on the homework, let's go over quick mistakes.
Was 1 on 37?
Yes.
Oh, was it the 0.5?
Yes. So the answers in both of these mistakes are 100% correct. So you might not even have noticed a mistake because you had it correct and I had the correct thing circled. Let's see if I can find those. I may have lost them. Oh, here we go. So the first one I made a mistake on in the notes, but the answer is actually right, is number 37. I did change it. I didn't change it online, but it's changed in my notes. Online, the mistake I made was I actually did 0.5x and I had 0.6x. I didn't move the decimal place twice. And so this would have been 0.5x plus 0.6 times. But I did make the change to be 0.05x and 0.06 for our things. The total still is the exact same. Like I said, I calculated it first, and then I went back and filled stuff in. Yes?
How did you get from that equation to 48,000?
Just by solving it, I guess. So you just have 0.05x plus 0.06x plus...
600.
Yeah, I almost said 60. Would have been way off. 600 equals 580. Then you have point, so we have 0.11x.
Yeah, I know what I have.
Okay.
6,000 instead of 600, so like the...
I almost did 60.
It's gonna be negative.
Yeah, okay, yeah.
I think it was 6,000 when you used the 0.5.
If I used 0.6, it would have came out. Yep. So we have to use that 0.06, yeah. So like I said, I solved it. So I basically did this and then worked backwards and then worked to here, which is a terrible way to do it. The other one I did make a mistake on. It is just a huge blunder on my part not to show you what I did. And it actually looks like a terribly horrible problem. It is number 57. So 57, I read something and I completely neglected it to put it in here because it was kind of useless information. I mean, it wasn't useless, but it didn't affect the answer at all, and I didn't write that why I didn't address it, I guess. So if we read the question, they're actually talking about quarter pounds. They're talking about a quarter pound here. They're talking about a quarter pound here, and they're talking a quarter pound here, and they talk about pounds right here. Why I didn't address it here, and I did at one point, and then I erased it, and I was going to put a little note, and I forgot to note it. To deal with the quarter pounds, you would have to multiply both sides by 4. Because you'd have to multiply this by 4, and our total cost by 4. So you basically multiply both sides by 4. Your 4s would cancel out, and you don't actually have to care about it being quarter pounds. That being said, this question on a test would not have those quarter pounds in it. They would be strictly pounds, because I want to see, can you read a question? Not can you in detail do this and figure out where 4 goes and stuff. I'm more worried about reading it, tables, and so on and so forth. Okay? So I did not address the fact that they're quarter pounds. I should have put a little blurb on here, and I forgot to, about why I didn't even deal with it, because at the end I just had to multiply everything by 4. But if you multiply both sides of an equation by 4, So if I would multiply this side by 4 to deal with the quarters, I'd have to multiply the end price by 4 to deal with the fact that that was price per quarter pound. The 4s would cancel out, and I would just not have to worry about it.
So how did you work if you didn't do it? Or did you just multiply and then write it out?
I just knew I didn't need the information, and I did put it in here at first. You can see like the 4x. I did have the 4s in there at one point, but it made a really messy problem when I knew the 4s were going to cancel out. So I was going to write a blurb about the fact. So if I was going to actually deal with the quarter pound issue, right, I would have to multiply basically all of our prices would have to be multiplied by 4 because these prices are for a quarter pound price. So to get a full pound, I would have to multiply all of these by 4. But what that ends up doing is just putting a whole bunch of 4s. But all the 4s would just cancel out. So because we are just dealing with all quarter pounds, treating it as a whole pound works as well, just because it's all dealing with quarter pounds. Okay? So I should have put a little blurb there and I forgot. But the answers, whatever answer you got, whether you did with quarter pound or whole pound, it's all going to be the same answer. All right. Based upon that, what questions do we have from the homework? Because that one could definitely have raised a question. Yes, Nick.
39.
39 is a definite mixture problem. So we have a north side assembly plant with 5% of the workers were classified as minority. And at the south side assembly plant, 80% of the workers were classified as minorities. So we have a north side, we have a south side plant, and they're combining them into an east side plant. So I should have a table where the first column is north, south, and east, or the mixture. Then we'll go and come up with our top columns. Well, we know we have percent of minorities, so we should have a percent column. We should have how many workers we have column, because they do talk about if 50% of the 1,500 employees at east side, so the total number of workers. And then we should have a total number of minority workers. That should be our table. So let me take a picture of mine, and we'll talk about how I filled it in. So here's the information they actually gave me, and I'll give you the information that I figured out from there. So they gave me that there's 5% in the north, 80% minorities in the south, and they gave me 50% in the east. They also gave me there's 1,500 people at that east plant right now. So 50% of the 1,500 employees at east are minorities. Then it said how many employees did north side and south side originally have. So this is really all the information they gave me. I had to figure all of this out. So I came up with this equation, and that is the percent minority times the number of workers is going to equal the number of minorities I have. So I don't know how many were at North Shore, so I just, north side, so I just made it an X. The people at the south have to be 1,500 minus X, because if there's 200 people here, there's 1,300 people there. So it's 1,500 minus X. There's our total minus X. And then just keep going. Percent times X equals our minority workers, 0.05 times X. 80% would be 0.8 times that 1,500 minus X. And 50% times 1,500 equals 750. So this plus this has to equal 750, which comes up to 600 is our X. So 600 people at north, 1,500 minus 600 is at south. Other questions? Yeah.
For 33, why did you use 8
For Bob?
like when you're doing the equation?
Mm-hmm.
Why'd you use 8 and not like 8 over 90 and not like 10 over 90?
Because my hint was the fact that I don't care that Bob already did 2 laps. That actually doesn't even factor into... The question, honestly, is Bob is going to do 8 laps in the time that Rick does 10 laps. because Bob already completed 2 laps, and they said that's when Rick started going. So Bob only has 8 laps to do. Rick has to do 10 laps. And they have to do this in the same amount of time because they're going to finish at the same amount of time. So both these times end up having to be the same. So that's why I put an 8 here and a 10 here. They also said that Bob was going 90 miles per hour. Where does it say that? It says it somewhere, right? Yeah. It said that Bob is averaging 90 miles per hour. So we got that, this, and this all from the problem. We got that he has 8 laps for his 10 to complete. He's going 90 miles per hour. So to calculate his time, then do our distance divided by our rate, which equals 4/45. Rick has to do this in the exact same amount of time because they're going to finish at the exact same amount of time. So they both have the exact same amount of time for Bob to go 8 laps and Rick to go 10 laps. That's where the 8 and 10 came from. Does that make sense, I guess? Okay. Other questions? Yeah.
A similar question. For the Batman one, the number has a 4, so I can't see which number it is.
Oh, yeah, 43.
Alright. Is the 24 of that equation just because it's like one day? Or they come like from somewhere?
No. The 24 is just the clear fractions.
Oh.
It is my lowest common denominator to clear the fractions.
Oh, okay.
Yeah, that's it. I just cleared fractions. That's where the 24 came from. So I should probably mark that, and I will mark that right now. I'll mark that as my LCD. Sorry about that. Yeah, it's kind of terrible that it does match 24 hours, right? Nope, just clear fractions. Other questions? All right, then let's get into today's notes. Now, if you're someone really good at memorizing formulas, then this lesson is really not going to be for you. This is more for people that are like me that hate memorizing formulas because you have 50 formulas floating around your head and you're not sure which to use when. So we're going to talk about the distance formula, and rather than just giving the distance formula, I'm going to talk about how you do this without knowing the distance formula, how you can solve this problem without even knowing the distance formula. And the distance formula is just the Pythagorean theorem. That is our distance formula, is the Pythagorean theorem. And so the first thing we're going to do is we're going to cover the Pythagorean theorem. And that is, if you have a right triangle, the Pythagorean theorem says that our hypotenuse squared, we'll say x squared, equals our side squared, and let's not do that. Let's go back to just a squared plus b squared equals c squared, where c is my hypotenuse. So in this example, we are going to have 15 squared plus 20 squared equals that mystery thing squared. I'm going to go ahead and call it x. I hate putting question marks. I don't know why I put it on there. I should have put an x. But we have 15 squared plus 20 squared equals x squared. When you solve this, what do I get x equaling if you've already done it? Yeah. 25. So when you solve this, you are going to get 25. Solving it is not the key to this problem because you should be able to solve this on your own. All right, applying this principle and 2 very distinct picked points. So if I had to plot 0, 1 and 4, 4, so this is my 0, 1. This is my 4, 4. And if asked to find the distance between them, if I had no idea what a distance formula was, I would just use geometry to solve it. And to use geometry, we're just going to create a right triangle. Well, we have all the information I need to get those 2 sides. We could just count the units. On the bottom, we have 1, 2, 3, 4 on the bottom. On my other side, we have 1, 2, 3 units there. So if I have side 3, side 4, what is my hypotenuse with doing no work?
5.
Yeah, it's a 3, 4, 5 triangle. I am not going to put that on here. Instead, I'm going to say, well, this is 3 squared plus 4 squared equals my distance squared. In other words, our distance is just going to equal 5. Either you do the math, or you know it's a 3, 4, 5 triangle. Our distance equals 5. That is the distance formula. You just used the distance formula. We just didn't officially put anything down yet. So we're going to move on and come up with two kind of random points where I don't have down. Yeah. So we're going to move on to 2 points that are just random that don't have values given to them. So we're going to come down here and we're going to say, well, this is going to be the point x sub 1 comma y sub 1. It's some random point. Then we're going to pick this point as being our second point. So we'll call it x sub 2 and y sub 2. It just stands for my second point. Well, we're going to think along the same lines. To get my distance, I'm going to create a right triangle. And I just need to come up with those 2 side lengths. Well, to come up with any length, if I give you a 4 and a 6, and I ask you the length between those 2 things, you're just going to do 6 minus 4. The length between them is 2 units. That's exactly what we're going to do for these lengths. We're going to take the bigger value, and we're going to subtract the smaller one away from it. So to get this bottom one, we are going to do x sub 2 minus x sub 1. My bigger x value minus my smaller x value will give me the distance between those 2 things. To get the distance between my y values, you're going to take your bigger y value and subtract away your smaller y value. That will get your distance. So these are just your distance between your x's and your distance between your y values. Those will give you your sides. Well, if I told you that and I told you to solve for d, you would once again use a squared plus b squared equals c squared. In other words, d squared is going to equal the side with x's in it squared plus the side with y's in it squared. And once you solve that, you have your distance. It's just a squared plus b squared equals c squared. Well, if I asked you to solve for d, you'd end up taking the square root of both sides. That's why our distance formula does not have a square in it. Instead, it's going to have a square root symbol in it. It is going to be the square root of basically a squared plus b squared. And so this formula always goes back to just a squared plus b squared equals c squared. It's a geometric problem. All right, now we're going to go ahead and find that distance if you haven't already. So our distance in this one is going to equal the square root of, let's go ahead and label some stuff. Well, I'll label that first point x sub 1 would be that 5. My y sub 1 would be that negative 3. My x sub 2 would be that negative 1. My y sub 2 would be that negative 6. All right, so we're supposed to do x sub 2 minus x sub 1. So my x sub 2 is negative 1, so we'll do negative 1 minus 5, and we're going to square it. Then we're going to add our y sub 2, which is negative 6, and we're going to subtract. Be careful here because I am subtracting a negative 3, so that's actually going to turn into a plus 3 situation. Be careful on these. These are easy to put negative 6 minus 3. It is minus a negative 3. All right, working this down, we're going to have negative 1 minus 5 is negative 6. Negative 6 squared is 36, so we have square root of 36. Negative 6 plus 3 is a negative 3 squared is 9. So this actually equals square root of 45. But I did put an equal sign next to it because square root of 45 is not my final answer because we can actually simplify that. What is the simplified form of square root of 45? What was that?
What?
Did you have an answer?
3 square root of 5.
It is 3 square root of 5. Yep. That'll be 3 square root of 5 would be my final answer. I do want you to simplify when they're that small. If they're big, like 645 or something, I don't expect you to simplify it. I don't want you to go through all of that trauma of dividing by perfect squares. But 45 you should be able to simplify. All right, that is the distance formula. Your takeaway from this lesson: I am not wasting your time by going through this stuff. I could have just given it to you because that really is. I care more, can you come up with the formula versus do you memorize it for the test? I want you to think, can you actually come up with this formula? So when you're doing these problems, just think about triangles and think about how the formula is developed. All right, finding the midpoint. Once again, I can just give you the midpoint formula, but I want to talk about where it comes from. So the midpoint formula just comes up, well, midpoint is just the average between 2 points. Well, we're going to start at the very basics of averaging something. The very first time you talked about averages, you probably talked with something like find the average of 80 and 100. In which case, hopefully you would do 80 plus 100 and divided by how many items you have. We have 2, and that's going to equal 90. Then you might have upgraded it to more of an algebra type thing where they give you 2 points on a number line. They give you -5, and they give you 3, and they tell you to find that midpoint. Well, the midpoint is just the average between those two numbers once again. So to find my midpoint, all you have to do is -5 plus 3 divided by 2 is going to be -1. So my midpoint should be right here. And it in fact is our midpoint because there's 4 units on either side to get to those 2 points. So that means the midpoint formula of A and B, anything on a number line, would just be take your A plus your B and divide by 2, and it's automatically going to be smack dab in the middle of those 2 points. Well, that's on a number line. Now we're going to upgrade this to an XY coordinate plane. So first of all, we're going to fill in some information. So the midpoint is halfway between the 2 endpoints. But remember, an XY plane is made up of 2 number lines, an X number line and a Y number line. So we just have 2 halfway points we need to find. We need to find its X midpoint, which is halfway between your 2 X values. And finally, you're going to need to find your Y midpoint, which is halfway between your 2 Y values. So how this is going to kind of look. So we have 2 points here. We have B and we have A. Let's call point B. We're going to let X sub 1 and X sub 2 stand for that point. And for our A, we're going to let X, oh, I'm sorry. That was already on my next one. X sub 1 and Y sub 1 will be my point B. Our other one is going to be X sub 2, Y sub 2. So we have point 1 and point 2. Well, remember with XY, we have an X component and we have a Y component. For this point B, if I was to plot this, I would go over some distance and then I would go up some distance. So we are going to go over X sub 1 units. And then we're going to go up Y sub 1. I don't really have room, but we have a Y sub 1 there. To get our second point, we're going to go on the x-axis, X sub 2 units along the x-axis. And along the y-axis, we're going to go Y sub 2 up. These are my X components, and these are my Y components. Now all I have to do is find the midpoint of my X's to get this point. So to get that middle point between our 2 X's, we just have to do X sub 1 plus X sub 2 divided by 2 gives me that midpoint there. To get my midpoint of my Y values, we just have to do Y sub 2 plus, I should probably do it in order, Y sub 1 plus Y sub 2 divided by 2 is going to give me that Y axis. So that means point M. Point M is actually the point x1 plus x2 divided by 2, comma, my y value be y sub 1 plus y sub 2 divided by 2. That gets me point M. It gives me my x component halfway between my two x values. It gives me my y component, which is halfway between my y components. And that point will be the midpoint between A and B entirely. So in fact, what happened right here is our midpoint formula. So our midpoint formula is just that point M. Find your halfway point between your x coordinates and find your halfway point between your y coordinates, and you now have your midpoint. All right, real quick for your homework. Number 1379, you are supposed to give what point correlates to that letter. You're also supposed to put which quadrant it's in. If it's not in a quadrant, you are going to either put x-axis or y-axis or origin. All right, those are three answers that wouldn't be in a quadrant. The rest are finding our distances, our midpoints. Number 23 is simplifiable. You'll still have a square root, but you can simplify it down a bit. And then you do have two word problems. My hint is you don't really need a table for the first one. It really is just adding things together to equal something. And then the last one, you do need a table, or you don't have to, but a table can be useful in that one. All right, go ahead and get started. I am going to walk around.